Today, we're going to explore something called the perception gap. We're going to see why one of the most advanced AIs in the world, something that can process trillions of words, sees text in a way that is fundamentally different from you and me.
Have you ever had this strange experience? You ask a really powerful AI to do something simple with letters, and it gives you this confidently wrong answer. It can write a beautiful poem or debug complex code, but it trips up on tasks a first grader could do. The reason for this isn't carelessness, and it's not a bug. It's something much, much deeper about how the AI actually sees the world.
Okay, so let's dive right in with a simple test. We're going to give the model a task that, for any human, is purely mechanical. You don't need to understand the meaning of the words at all, you just need to manipulate the symbols.
So the prompt is simple. Just reverse this phrase. For us, the process is practically automatic, right? Our brain just goes to the last letter, S, and puts it first, then B, then A, and so on. We are operating on the individual characters without even thinking about it.
Now let's take a look at what the model gives us back. At first glance, it seems pretty good. The word order is reversed correctly. You got labs, AI, Jatra. Some of the words are even spelled backwards perfectly. But if you look closely, it's not quite right, is it?
So it reversed labs as spell, which is perfect, but then it reversed Jatra as Artia J. Notice what it did? It flipped the chunks, J and Tra. Now, this is the point where our first instinct is to just say, that's a silly mistake. But this specific error isn't random. It's actually a clue, and it's revealing something profound about how the model works under the hood.
To see that this isn't just a one-off fluke, let's try a different example. We're looking for a pattern here, a consistent behavior that points to a systemic difference in how it processes text. Here's another task that is incredibly simple for us. To get the answer, we just visually scan the letters one by one. S-T-E-R, there's one. A-W-B-E-R, there's two. R-Y, and that's three. Easy.
But the model gets it wrong, and for a very long time, this exact kind of question stumped even the most advanced models. This reveals a critical piece of the puzzle. The model does not scan letters. It literally cannot perform that kind of operation.
So on the surface, reversing a word and counting its letters seem like completely different problems. One is about order, the other is about quantity. But to the model, they aren't different at all. Both of these tasks collide with the exact same structural limitation.
So, to really understand why this happens, we have to adjust our most basic assumption about what it even means to read. We have to try and see text the way the AI does. When you and I look at this phrase, our brain immediately breaks it down into its most fundamental parts, individual letters and spaces. Our entire system of reading is built on that foundation of characters.
But here's the thing, the model never saw letters. From the very beginning of its training, it was taught to see the world in chunks, or what are called tokens. This visualization shows that difference perfectly. To the model, Jitra AI Labs is not a sequence of characters, it's a sequence of 4 tokens, Jai, Tra, AI, and Labs.
So what exactly is a token? Well, you can think of it as a statistically common piece of text. It might be a whole word, like labs, or part of a word like Jai, or sometimes even a single character. These tokens are figured out once by analyzing huge amounts of text, and then they become the unchangeable, fundamental building blocks of the model's entire world. And with this single insight, that models see tokens, not letters, those silly mistakes from before suddenly make perfect sense. We can now see exactly why these simple human tasks break the system.
See, reversing a word or counting its letters requires you to have direct access to those individual characters. But the model simply doesn't operate at that level of representation. It sees the token strawberry, not the letters S-T-R-A-W-B-E-R-R-Y. Its entire job is to predict the next most likely token, not to dissect the ones that are already there.
And this is the absolute key. The failure isn't because of missing logic or because the AI isn't smart enough. It is a fundamental mismatch of representation. The tasks we're asking it to do are in direct conflict with how its perception of language is encoded. We're essentially asking it to find a screw with a hammer.
And this isn't just an interesting little puzzle. This perception gap has very real, very important real-world consequences, especially as we start to rely on these models for more precise and critical tasks.
Just think about it. Any task that depends on the exact sequence or the exact count or the position of individual characters is fundamentally misaligned with how this system processes text. This includes things like verifying a serial number, matching a specific piece of code, or even understanding simple wordplay.
And this gets us right to the heart of what we call the perception gap.
Humans perceive text as a visual sequence of discrete characters. LLMs perceive it as a probability distribution over statistical tokens. Neither one is wrong, they are simply different cognitive systems built for completely different purposes.
So let's just recap the core idea here. Understanding this mechanism is the key to working with these models effectively, and for seeing both their incredible capabilities and their inherent limitations.
The logic is actually very clear once you see it. We perceive letters, models perceive tokens. So when a task requires letter-level access, that structural mismatch is going to cause a predictable failure. Once you understand how the model sees, its errors stop being mysterious. They become logical, predictable outcomes of its very design. This leads to a final thought. We've just seen that our most basic assumption about reading, that it involves letters, is just plain wrong when we apply it to AI. It really forces us to ask a bigger question. What other assumptions are we making about how these systems perceive, reason, and understand the world around them?
This fundamental difference in perception is one of the keys to truly understanding how these powerful systems work. Thanks for joining this explainer, and we'll see you next time as we continue our deep dive into the mechanics of AI.